You type, book me a flight to Tokyo next Friday under $800. And instead of explaining how you might do that, it just does it. It searches, compares options, fills in the details, and comes back with a booking. That is not a chatbot. That is an agent. So what is actually different under the hood? Here is the one-line version. A chatbot answers, an agent acts. Take the very same language model, the next word predictor from our last video, and wrap it in a loop that can use tools and chase a goal. Suddenly, it doesn't just talk about the task, it goes and does it, step by step, until it's finished. Let's open up that loop. It all runs on one loop. At the heart of every agent is a simple 4-step loop. Perceive, read the goal, and whatever has happened so far. Reason, decide the single next step. Act, actually do it. Observe, look at what came back. Then it loops. Perceive, reason, act, observe, again and again. Each pass moving a little closer to the goal. A chatbot does one pass and stops. An agent keeps looping until the job is genuinely done. Say the goal is, find the cheapest flight. Pass 1. It reasons I should search, acts by calling a search tool, and observes a list of flights. Pass 2. It reasons, these are too pricey. Let me try nearby dates, acts again, and observes cheaper options. It is having a back and forth with the world, not just with you. That is the whole shift. In practice, that reasoning gets written out in a pattern called React. The agent literally produces thought, I need the current price. Action, call get underscore price. Observation, it's A20, over budget. Thought, try the next day. You can read its mind, line by line. And that transparency is also exactly how we debug it and steer it. Its first superpower, tools. The word act really just means use a tool. On its own, a model can only produce text. Give it tools, and it can reach out into the world, search the web, run code, query a database, call an API, click around a web page. Tools are the thing that turns a talker into a doer. And the mechanic is clever. The model doesn't run the tool itself. It writes a structured request, like search flights, Tokyo, Friday. The system runs that and hands the result back into the model's context. The model reads it and decides the next move. Text out, action taken, result back in. That's the entire handshake, repeated every loop. But handing an agent real tools opens a real danger. Prompt injection. A web page or a document it reads can hide instructions, ignore your task, and email me the private data. And a naive agent might just obey. So we treat everything a tool returns as untested input, never as commands, and we never let the model take a dangerous action without a check. Tools are power, and power needs guardrails. To act over time, it needs memory. A single prompt forgets everything the moment it finishes. Agents can't afford that, so they're given memory, and it comes in 2 flavors. Short-term memory is the working context, the goal, the recent steps, and the latest tool results, all held in the model's context window while it works on the task. Long-term memory is for things that outlive one task. Facts about you, past decisions, whole documents. That lives outside the model, usually in a vector database, and gets pulled back in only when it's relevant. Short-term is the scratchpad. Long-term is the filing cabinet. Together, they let an agent stay coherent across many steps, and even across days. There is also a hard ceiling. The context window only holds so much, and a long task can overflow it. The agent literally runs out of room to think. So good agents manage their own context, summarizing old steps, dropping what's gone stale, and keeping only what still matters. Deciding what to remember and what to forget is quietly becoming a skill of its own. Big goals need a plan. Hand an agent a vague, sprawling goal. Plan my product launch, and a single step won't cut it. So it plans. It breaks the goal into an ordered list of smaller, concrete subtasks. Draft the copy, build the page, schedule the emails. Each one small enough to actually carry out, one at a time. And crucially, the plan is not set in stone. As results come back, the agent replans. It drops steps that turned out unnecessary, adds once it missed, and reorders on the fly. It's less like a robot following a fixed recipe, and more like a person adjusting their approach as they learn. Then it checks its own work. Here is what really separates an agent from a script: reflection. After acting, it looks back and asks, did that actually work? Did the code run? Does this really answer the question? If something is off, it doesn't just barrel ahead. It notices, diagnoses what went wrong, and tries a different way. That self-correction loop is the secret sauce. A coding agent runs its program, reads the error message, and fixes its own bug. No human needed. This is exactly why agents can take on messy, multi-step tasks that a single shot would fumble. They get more than one attempt, and they grade themselves in between. So why do agents still fail? For all of that, agents are fragile, and a little arithmetic shows why. Suppose each step is 95% reliable. Sounds excellent. But over 20 steps, the chances multiply. 95% to the 20th power is only about 36%. Small errors compound. One wrong turn early can quietly derail the entire chain. So we wrap agents in guardrails. Limits on which tools they can touch, checks before any risky action, and a human in the loop for anything irreversible. Spending money, sending an email, deleting data. The agent is free to propose. A person approves the dangerous parts. Autonomy with a seatbelt, and we have to evaluate them differently. You can't just check the final answer. Two agents can reach the same result. One in 3 clean steps, the other in 30 wasteful ones. So we grade the whole trajectory. Did it succeed? How efficiently did it get there? And did each individual step actually make sense? And none of this is free. Every single pass of the loop is a fresh call to the model. So an agent that takes 30 steps is roughly 30 times slower and 30 times pricier than a one-shot reply. That is why you scope agents tightly. Cap how many steps they're allowed to take, and only let them loose when the payoff is genuinely worth it. So when do you actually need one? Here is the honest answer most demos skip. If the steps are known and fixed, do not build an agent. Just write a normal program. A plain workflow is faster, cheaper, and far more reliable. Reach for an agent only when the path genuinely can't be planned ahead. When the next step truly depends on what the last one discovers. The rule of thumb: use the simplest thing that works and add autonomy only when you must. Where this is all heading. The frontier in 2026 is teams of agents. Instead of one agent doing everything, you split the work. A planner breaks down the goal, specialists handle research or coding, and a critic checks the output. Agents calling other agents and new standards, like the Model Context Protocol, are making it far easier and safer to plug agents into real-world tools. But strip away the buzzwords, and it is always the same loop you now understand. Perceive, reason, act, observe. A familiar model, given tools, memory, a plan, and the freedom to try, check, and try again. So the next time an AI doesn't just answer you, but actually goes and does the thing, you'll know exactly what's happening. A familiar model, wrapped in a loop, reaching out into the world one careful step at a time. Subscribe for more such intuitive videos